Okay. Solve for theta being between 0 and 360, giving your answers to one decimal place where appropriate.
Gonna write it out quickly. Okay, so we want to divide cos theta over. So you'll have 2 sine theta over cos theta equals 3. So tan theta equals 3 over 2. Is that correct?
Tan theta is 3 over 2. Love it. Keep going, keep going.
So now we want to do the inverse of tan to obtain our angle. Inverse of tan of 3 over 2 is equal to, is 56.3 degrees. So,
how would you get the other solutions?
using the cast diagram,
Okay.
or using the tan rule.
Yeah.
Which is
tan
plus,
was the nicest rule, actually.
Yeah, so plus or minus 180 degrees, but I'm going to use cast. 56.3, so 180 plus 56.3 is 236.3, and those are our only two results. Okay, question B.
Awesome.
2 minus cos theta equals 2 sine squared theta. So we want to square this, the left-hand side, right?
We want to square the left-hand side. Why?
Well, we want the we want cos to be squared as well, so that we can use the identity of that.
If you square the left side,
You'd have to square the right side. So
I have to think of something else.
well, essentially, sine squared is sine times sine, so we can divide one of them over, right? But then I don't know.
But
what
then
to
you
do
got
for
cos over sine, something something equals
that.
sine,
Yeah.
right?
Okay.
Do we know an identity that can convert sine squared? Because here's the thing, because we haven't.
Oh no, sorry, it's 1 minus cos squared.
Okay.
Yeah.
Because we want either everything in terms of sine or everything in terms of cos, and because we have that sine squared, we can make it in terms of cos. Yeah.
Okay, so 2 minus cos theta equals 1 minus cosine squared theta. Okay.
So tell me what you did there, because I see the sine squared.
Oh, sorry, 2.
Yeah.
I need to do 2 minus 2 cos squared theta. Is that all right now?
So 2 minus 2 cos squared. Yes, 2 minus cos squared. So exactly. So from there, what happened there? Glitched out. Yeah, so exactly. So straight from there, that's what we want. I think this step is then therefore incorrect.
Oh, no, that was just the identity.
Oh, you're just writing the identity. Okay, I see what you mean. Cool. Yeah, so from there, let's keep on going.
I don't need this many cosines, so I'm going to divide it over.
Divide it over. What do you mean by that?
Well, I want to, because cosine squared over cosine is just cosine. So I want to simplify it to make it easier to solve, right?
But remember, we've got like 2's in there, right?
Okay.
And if we have 2 over cosine,
It'll become
then
2 cosine. But
no, it wouldn't. It'll be 2 over. We're dividing by cosine. That's what you said,
Okay.
right?
yeah, because we have to divide all of it. Okay.
You will come across this kind of situation a lot, by the way. So
Okay, well,
let's think about this.
so essentially, well, no, minus cosine theta is equal to minus 2 cosine squared theta is essentially what it's saying, because it's 2
That's
minus.
True. That's true. What else could we cancel out?
Well, I want to simplify this. So I cannot divide minus 2 cosine squared by minus cosine.
No, I wouldn't do that. I see why you would. But remember, okay, so we went across a very similar situation previously. I'll give an example. Imagine you have x equals 2x squared. And maybe your thought was initially to divide by x, so it becomes this, right? Yeah. But I said, wait a minute. We need to keep that that extra x, because
Then you can do a quadratic with it.
exactly, you could do a quadratic with this. You can make it 2x squared minus x equals 0. Factorize it. Oh, the x comes out. You have 2x minus 1. So the previous method, you just had the 2x minus 1 equals 0. But with this method, you can see we've got the x as well. Therefore, x is not only 1 over 2 from the 2x minus 1, but also 0. Yeah. We're going to do something similar here in this case. So what if we took that minus 2 cos squared and we chucked it to the left side?
So 2 cosine squared. Oh, oops. So 2 cosine squared theta minus cosine theta is equal to 1.
Is it equal to 1? Because if we added minus 2 cos squared to the other side, is
just
there anything
0.
left? Yes, just 0.
Sorry, I thought we were dividing for a second.
Yeah, no, that's fine. Now, what does this look like compared to my example?
It looks like, well, you know what we'll do? Just to make it simpler in my head, I'll let x equal cosine theta. So 2x squared minus x equals 0. So x, 2x minus 1 equals 0. So one of the cosine thetas has to be equal to 0. And the other one is equal to a half.
Exactly. So cos is either equal to 0 or a half. Okay. And we can get solutions for theta from both of them, right? And we just need to remember from the question, what did it say? That theta is between 0 and 360. So those are... that is our...
So 0 and 360. So we'll end up with theta equals 90 and 60. I'll do it the other way around. 60, 90. So...
Is that from half?
Yeah, so I did a half and 0. Yeah.
60 and 90?
Yeah, because inverse of 0 and inverse of a half. And then I'm going to do the other ones.
Oh, I see.
I haven't done all of them yet.
Okay.
So, well, using the class diagram, the first one is 60. And then we'll be 60 away. So 300 is the other one.
Yeah, 360 minus 60 is 300.
And then, or rather, we'll do it this way. Just using the, should be 270 and 300, I believe.
Yeah, 360 take away 90 is 270 as well. Brilliant. Yeah, so those four are our solutions. Love it. Nice.